My name is Enrique Ramírez. I'm a software engineer at Tesco. And today I'm going to talk about something that is a little bit unusual for a droidcon, but it's something I really enjoy. And let's kick in. So, I'm going to talk about hardware development with KMP multi-platform, but I'm going to do it through one of the things that I like a lot, which is guitar pedals and guitar pedals, and it's one of my passions. So let's explain first what is a guitar pedal. So a guitar pedal is just something that changes the signal of takes the signal of your guitar and it transforms it into a different thing. So you can get a different effect and a different sound. And just to bring it to the programming world, we can think of this like in reactive programming or in reactive programming on functional programming. We can consider the guitar to be like an input stream, and every effect is basically a mapping function. So we keep transforming it, and we can change it. So we can create many different combinations of them. We could use so many of them, and from distortions to some echoes, delays, compressor, equalizers. But it's similar in a way to what we do with streams in functional programming. So and this is a little bit like in the programming world, we like to brag about our setups, how rate my setup, in my screens and everything. But in guitar players are kind of the same and even worse. They love guitars, they love pedals, and they like collecting them and combining them. And the more the merrier. They all sorts of things. They really like guitar pedals. But what do you do with them? So you can combine them to create actual sounds. And for different songs, you use different sounds. Or even in the same song, you have different types of sound. So that's what it gives you. A combination of guitar pedals gives you a different sound. And there's a problem with this, especially with professional guitar players. One of the problems they have is when they are playing, they are live, they have to do some sort of aerobics to change from one sound to another. Like you want to have 3 pedals combined, you need to switch lots of them super quickly in one go, and then you go to the next sound and you go and have to do that again. So I came up with this idea of having a guitar pedal switcher. That basically what it does is once you press a button, you have a collection of pedals arranged in a certain way, and just by pressing one button, and then if you are in another section of the song, you press another button and it does the arrangement for you. That actually exists in the digital world, where you just load a different, in the digital processors, you can combine all of that and those, and by pressing a button, you just load a different program. But in the analog world, where people still like the vintage guitar pedals, that's a little bit more difficult. So that's where this project starts. And let's see what are the requirements of this project. What we want is to be able to switch multiple pedals at once, just in one go. And then we want to some kind of way of displaying them, to have some graphic indication of what is selected with a screen or some LEDs. And then we would like to add some companion app. And so for that, we'll have to implement some kind of wireless communication. So let's explain a little bit more in detail what this switch does. So let's take this super simple example. These switches are also called cross-point matrix. And imagine we have these 3 pedals, the guitar and the amp. And let's say we want to connect the guitar to pedal 1, then from pedal 1, which is a compressor, goes to pedal 3, which is a distortion, one type of pedal, and then goes to the amplifier. And this is what the matrix does, just joins inputs and outputs. So the guitar goes to the input of the first pedal, then the output of the first pedal go to the input of the third pedal, and then the output of the pedal goes all the way to the amplifier. So we search online and we see what does this switcher and what can we find, and then you go into this website with electronic analog devices or microchip or text instrument, and this is the one I found. This is the ADG2188, which is a switcher that basically it takes 8 inputs and 8 outputs, and you can rearrange them how you want. And it says that it works with something called I2C, which we don't know what it is yet, but we'll get through that. And what they sell is those chips. That's the thing. They sell those chips, but we would like to be able to have. Oh, sorry, I'm missing an image. Anyway, sorry, one sec. Well, sorry, it didn't show in the presentation, but it's missing an image. But what we want is some kind of board that you can connect from a computer. Oh, it is there. Sorry, from a computer and talk to this hardware. That's what we want. So you need to do a little bit of electronics. That's not that close to what the kind of thing that we do as developers. But you need to do some schematics, and then after that you need to do some PCBs, get to a manufacturing service. And then I'm missing an image as well. Sorry. And then the final result is a board that you can control with some sort of computer. And you need to do some extra boards for the inputs and outputs as well. And yeah, if you want to go more into the prototyping and do something a bit more advanced, you need to get into 3D printing. For instance, I have the last version of the prototype, but I had to do many of this printing. I had one here if anyone wants to have a look at that later. And that helps you a lot with coming from a messy lab environment to something that looks more like a prototype. And how do we build this? So we are mobile software engineers, not embedded, right? Well, I will argue that we are some sort of embedded software developer, or at least at some point we were. And I don't know if if you watch this film, The Karate Kid. There's this scene where the Mr. Miyagi tells the main character to do a lot of chores that he doesn't like. He's upset with that. He wants to learn karate, and it turns out that actually those skills were useful for the karate, but he didn't know. So I will say that's a similar thing for us. There's some transferable skills, some things that we already know. We know a lot of things like architecture, testing, CI. Security, if you want, we know lots of things that we got as mobile engineers, that we can transfer those skills to the embedded software development in a way. And which platform can we use for doing this? So the original version of this that I made a couple of years ago, it was made with Android Things. I don't know if you remember Android Things. But actually, we have a room called Android Things for the things that Google killed. But Google, being Google, did what it did and edited it, and that was the end of that platform. But we have other things. We have the Raspberry Pi. Raspberry Pi is this amazing platform. It's a Swiss Army knife, and there you have lots of communication that come out of the box. You have very small factor, a lot of support from the community. It's amazing, and it's relatively cheap. Yeah, good, the Raspberry Pi. And then what software we put on it? We have KMP, right? Like KMP says that you can do it for server, Android, iOS, desktop, and web. Sorry, I'm missing embedded here, but why don't we just fix the documentation, right? Sorry, the animation is not. Oh yeah, embedded. So we could use the desktop target to build our app in our embedded platform, right? So we can easily build a KMP application with a JVM target, and then we can run even run Compose on it, thanks to Skiko and Skia, and that add these libraries. That Skia is the 2D library, and Skiko is the bindings. Like, but to summarize, is what let us run Compose on this target. And then you can write a UI like this. So super cool. We can now have an app that can have an architecture that we are kind of familiarized with, kind of cleanish architecture. When we have some UI presentation, use cases, and then some entity in the center, right? But that will be just the UI and stuff. We need to talk to the hardware that we mentioned before. So we have a deeper look at what the Raspberry Pi provides, and it gives us lots of ports. And then it turns out that there's 2 ports that are that I2C thing that we saw on that schematic, on that data sheet before. So yeah, this seems to be supported out of the box straight away. And we can connect a Raspberry Pi to our switcher, that our switcher later is connected to the pedals, and unconnect the screen somehow with the HDMI port and it. Let me drink a bit of water. So one thing that I saw I love the Raspberry Pi, I love the community, but one of the things I saw is like there's almost everything is Python. Most of it is Python, and like I want to use the Java target, and I want to do everything with Kotlin, and basically it. So I found this very nice project called Pi4j that lets you. Sorry, I selected too quickly. Lets you talk to these ports that I mentioned we showed before, and it's very easily with a DSL. It's super flexible. Like you can kind of give your providers of how you talk to those if you want a custom thing, and it is compatible with multiple boards. So I found this project amazing. Actually, talked to the creators afterwards. So it supports I2C, and then another thing that we will need for later is GPIO. So this library is perfect for us. So and to explain a bit deeper what the I2C protocol is, it's just kind of a protocol to talk to circuits that allows you to connect many target devices and control with a main one, and with only 2 wires. That's the cool thing. The only caveat here is that you have to handle addresses. So every little device that you can control will have a different address. In our case, in this first version, we're just controlling one device. So, but if we want to extend, it seems like a good protocol to it. And if we go to the data sheet of this chip that we want to talk to, we see that we actually need to construct the data that we are going to send, and it has 1 byte for saying the address of the chip. That if you have noticed on the previous image, there has some DIN switches. You configure that there. Then you need to set what input and what output you are gonna join together, or enable or disable. And then whether or not the last byte is just for saying if you want to keep sending messages. So it's like a latch thing. So you send a lot of commands like I want to configure these 3 inputs and outputs, and then you need to specify with the last one whether or not you carry on sending this data or you want to change all at once, or you have finished, so it changes all at once when you finish. So just a very simple example. I know this is a bit too deep, maybe too low level, but let's go quickly on it. So that's the important byte that we define. That is, what it's doing is what we explained at the beginning of joining inputs and output. We just need to say whether or not that route is on or off, and then the address of the input. So it's binary for the number of that port and the output one. Sorry, it didn't render well. So. Oh, sorry. It wasn't. Sorry. Anyway, okay. So, and this is, and with a Py4j, very, very easy to do. Like we have a DSL. You just need to define. Sorry. We need to open Py4j that gives you something that they call context, kind of like Android, and then you define the protocols that you're gonna use. You say which is the bus that you use and the address of it, and you give it a name. And then you need to specify the providers. That's one of the cool things about this library, that you can. It has lots of flexibility, so you could say how this is an abstraction of how you talk to this, and the provider is the actual driver that does the communication, and you have several ones, and you can play with that. And basically, we send the commands like that. Once you configure the device, you just call the device and call write. That's as simple as that. In our case, the only thing is we need to construct those bytes, and that's not too difficult. We just need to do a little bit of shifting and composition of a byte. You just need to say if it's enabled or not, and then convert the input index to binary. Same with the output, and then shift them so you construct the byte. Nothing too complex. Sorry. And that's fine. That's just to set one. But as we mentioned before, the whole state of the pedal switcher is like a matrix. So you need to set the matrix of all the arrangement every time. And you could do like reset everything and set them again, or what you could do is similar thing like we would do with things like Compose when or on an array list, on recycle views, where we only change the things we only update the things that change. We could do kind of the same thing here. So we can have the current state of the matrix. We subtract the new state. We get a diff, and those are the commands that we actually send. That's what we're doing there. So the first thing that we have to do is convert the list of the pedals that you want to select into a matrix, a matrix that only have 1 or 0s, enable or disable. You need to do the diff, and that's it, and send the command as we mentioned before with using Py4j. And now the app looks a little bit more complex. We have this driver, and it was working. This was the first version where you could, with UI, you could enable and disable, and that will rearrange. The first version, I did it with a Raspberry Pi 3, because that's the one I had around, and a bigger screen, but still I couldn't do the switching like pressing the button. So I thought on adding LEDs and buttons. Well, I thought it was part of the plan. And for that, we still can use the Pi4J that we mentioned, but we need to use different ports. This is the Raspberry Pi has something called the GPIO, is the General Purpose Input and Output, and now simply pins that you can configure as input or output, and you can do you can do all sorts of things, reading, writing, and that's it. And when we have a look at the Raspberry Pi, we can see that we have already used some, but we can configure the rest for this purpose without a problem. We have lots of them. Oh, sorry. And this is, for instance, an example of how to do the reading of one of these switches. It has a little bit of electronics, but it's just, there's two options. There's whether or not you can see the 3.3 volts to be press or a 1 or the other way around. So that's what they call pull down or pull up resistor, but I'm using pull down in this case. And with Pi4J, very, very, very simple again. You just need to know what are you know the ports, the number of those ports in the Raspberry Pi. Adding some, say whether or not it's a pull-down resistor, adding some debouncing. That's something that we take for granted, but like in the old world, you needed to debounce like pressing a key, because it's not that straightforward. You could get a lot of ripple when you press on a button, but you have that you can configure how you want, and then you react to the pressing. And this is on high. This is exactly like having an on-click listener on a button on the UI, exactly the same. And with the LEDs, it's even easier. You just need to put a resistor and the LED and your pin, and then ground it. It's nothing complex, and it's even easier to define. You just need to know whether or not your LED is going to be on or off. Pi4J in the DSL, super nice and clean. Just specify the provider, and you're done. So now you can connect and switch pedals, pressing the buttons. Switch, change pedals, rearrange pedal by pressing the buttons, and you have some indicators of which sets of pedal is connected, is engaged at that point. So what was the other thing that I wanted to do is adding some communication to control it with an app, or with an app mainly. And we have several options. We have TCP/IP base. We have Wi-Fi and HTTP on the top of that, or WebSockets if we wanted. Then we have things like MQTT. But I did the first version with BLE because it's very lightweight, and it was very easy to implement, and on the client side as well. And it's I'm trying to come up with other reasons, but it's a well-known protocol, and it works well, lightweight, very small communication for small chunks of data is perfect. And we just want to say, I want a set of pedals 1, set of pedals 2, and no more than that for the first version. But later, I haven't added yet, but I was thinking on adding another way of maybe customizing the whole thing and setting the presets and maybe adding images and that. And for that, you will need something like HTTP and the top of Wi-Fi. So not going too deep into BLE, but I'll try to be brief. And you do the communication on BLE through something called characteristics. So there's services and characteristics. You can see that as endpoints, like kind of in your APIs, but it's with endpoints you can do CRUD, right? This is kind of similar in a way. So you can read, write, or subscribe from the client in perspective, from the companion app perspective, and on the device that implements that BLE service, you can read or publish. So that's all we need, and not too complex. For creating a server in Java for BLE, I found this library, which wasn't maintained for a while, but it was a good starting point. As I said before, almost everything is done with Python, and it's difficult to find Java stuff sometimes for the Raspberry Pi. But I found this library that uses the dbus, which is a communication messaging thing that Linux implements. But I actually wrote my own version of it based on that, but also based on the Py4j library, a bit influenced by that, with a DSL, and I published it into Maven Central, but it was inspired on that. And that let us have our application, and below that there's all sort of stuff. There's the dbus that I mentioned, and the BlueS is the actual Linux stack implementation of Bluetooth. And this is an example of how I build the code, but I need to be super quick. And you just define the name of your server. You need to define UUIDs. That's it will be like your domain on an API, and the characteristics, it will be like the path on your APIs. And then whether or not, what are the capabilities of that characteristic, whether it's a writing one, a reading one, or notifying one that you can subscribe to. And then how you update that one. And you can define several ones. And this is a DSL. The first version was like a way chunkier stuff, but with the DSL, I thought it was a bit better. And yeah, no, going back before that. And yes, overall the architecture with everything, with the Bluetooth and the driver and the foot and switches, looks something like that. It's a bit more complex, but yeah, it's what it is. Let's do some demo. Let's see if we can have. I'm conscious of the time. We are a bit. Is this running? Yes. Still have some 10 minutes, but I think anything can go wrong. The demo is going to be super quick. It's just to show that it's working and what you can do. I'm a terrible guitar player, by the way. Just going to be. I'm so sorry. I mean, for your ears. But could be worse. I hope you can see it and hear it. Yeah, you can. So basically, if we every button have a different. Every time I press a button, it configures a set of pedals. That's what's called a preset. And by pressing the different buttons, I have a different preset. I select a different preset. So at the moment, just for demo purposes, everything is engaged. All of those pedals are enabled, which doesn't sound very good. It's a bit messy. But, oh, sorry. If I press this one, for instance, we could have, for instance, this kind of lo-fi sound or clean sound, but then we might be on a different section of a song, and maybe. And we want to play something like a distortion. And then I'm terrible playing, but imagine you can play a guitar solo, then you might select that one for that was basically the demo. So you could have. It was very brief. Sorry. Sorry, coming back. That was the demo. That was the one. But it was just to showcase that by pressing different buttons, you do the arrangement, and it actually works. It's not just the code and all that talk about the hardware. It actually works. And I want to talk a bit on this project of what is work in progress. So I want to add, as I mentioned before, a little bit of Wi-Fi communication and HTTP. Like we could use things like Wi-Fi Direct. And the reason being is like I mentioned with BLE, I can just select things very quickly, but the communication is very, very little. But if I want, let's say, tomorrow I want to add a feature where for each pedal I want to upload an image, I could do that through that. So we could have a very simple HTTP server that can run that without a problem. And we have things like Kato, and it's very easy to create just an endpoint with what you want. Maybe you want to see the list of pedals, or you want to you want to have one for getting them and one for posting them, which with whatever however rich you want to have your metadata or whatever you want to add. And what's in the future? I mean, this is a DIY project that I work when I have time, but I want to do lots of stuff. I would like to do that companion app I was talking about. Now everything, all those pedals are kind of hard-coded. I need to load a new version of the program, so having an edit mode will be good. Or adding like a MIDI port, like those the MIDI is that thing that musicians use to control their equipment. That will be super cool. Or I could use one of the capabilities of the Raspberry Pi to analyze the sound and maybe create on that screen, now that you have a screen, have a tuner or something. And I would like to play off how you do deployment of this kind of software in case I want to, in the future, I take it further. So having CI and see how you control like a bigger range of those, and how you deploy updates and stuff. So that was basically it. And you have the resources here. Yeah, actually, it was faster than I thought, but for a moment I thought we were going to run out of time. So I rushed a bit. But I hope it made sense and you enjoy it. Super cool. If we can do questions or anything. Oh.
You're great with guitar.
No, I'm terrible. I'm awful. But you can find me.
The rest of it we can play it in our head. That's what I was doing. We're all to something.
No, but if you want to catch me later, ask me anything about this, I'm happy to have a chat later. Thank you very much.